Section 26, question 2. As part of their training, footballers run around a triangular circuit, DEF. The angle EDF is 34 degrees, DFE is 82 degrees, the length of DE is 46.4 metres and EF is 26.2 metres. How many complete circuits must they run to cover at least 1,000 metres? So this question is asking us to first of all get something for the perimeter. Now the thing that's missing here is this side. So I'm going to proceed with working out this side. So if that's capital E, I'll call that small e. There's small f and small d. I'm going to just check what I've got. So I know that that's 34 degrees and that one's 82 degrees. And whether it's going to be of use to me or not, I've got a fair idea that it probably will. I'm going to find the third angle. Remember, angles in a triangle add up to 180 degrees. So 34 plus 82 is going to give me 116 degrees. That off 180 gives me 64 degrees. I'll then now identify this question as sine rule. I've got two pairs of opposites and one unknown. So E over sine E. So E, remembers the thing that I'm looking for, small e. E over sine E is equal to F over sine F. So that's E over sine E, and the angle up here is 64 degrees, is equal to F over sine F, and F is 46.4 over sine 82. I'm going to then cross multiply, so E times sine 82 will be equal to sine 64 times 46.4. So E will be equal to sine 64 times 46.4 divided by sine 82. So I'll just enter that into the calculator. And that will give me 42.1 metres. Now I've did a bit of hard work in getting there, so I can now say that this side here is 42.1 metres. The question says, how many complete circuits must they run to cover at least 1,000 metres? So I'm going to first of all find the perimeter by adding these three things up. So it's going to be adding up 46.4, 42.1 and 26.2. So 46.4 plus 42.1 plus 26.2. So I'm going to add them together. And that'll give me 114.7 metres. So one circuit, one perimeter. One circuit is 114.7 metres. If I then do 1,000 divided by 114.7, enter that into the calculator, 8.7. Now that means that we need 8.7 circuits, so the answer to the question is he will need to run 9 circuits to cover the 1000 metres. That's the end of the question. Okay, section 26, question 3. This is in a non-calculator paper, which is kind of unusual for sine and cosine rule questions. They don't tend to come up as much in non-calculator papers as calculator papers, so let's have a go and see how we'll proceed with it. In triangle ABC, BC is equal to 6 metres, AC is equal to 10 metres. Angle ABC is 30 degrees. Given that sine 30 is equal to 0.4, show that sine A equals 0.3. So as I say, it's looking like it's indicating that I should use sine rule here. That would normally come up in a calculator paper, but it's non-calculator, and let's just see where we go with it. So again, sine rule is 2 pairs of opposites, one unknown. So we need to show that sine A is equal to 0.3. Right, so I've got 2 pairs of opposites here, and here we go. So 10 over sine 30 is going to be equal to 6 over sine A. We need to prove that sine A can be written as 0.3. So I'll just do what I normally do with sine rule at this point, which is cross multiply. So 10 sine A is equal to 6 sine 30. The question then gives us a clue, which is that sine 30 is equal to 0.5. So that will now be 10 sine A is equal to 6 times 0.5, which is 3. Sine A is equal to 3, bring a 10 down, divide. 3 divided by 10 is 0.3, and that's the final answer to the question.